All right, this is one of those lessons that, I don't know, it just kind of stands out, okay? It's one of those really important lessons that, that is just so familiar in geometry, you just wouldn't understand, okay, until later on. So this is a crazy important lesson, so I want you to take good notes. They actually do this pretty slow, okay? A lot of books might throw a whole bunch of these postulates and that's what we're going to do, congruence postulates. They throw a lot of them into just one lesson. This one only gives you, 2 of them. I didn't take notes on this. I don't know why I didn't. I probably need to do it so next year I can just pull out my notes. So I am looking at the book. So yeah, we're going to do 2 postulates, and then we're going to do some theorems. Not today, but we're going to do some theorems. They really kind of look exactly the same, the theorems and the postulates. But what's the difference between a postulate and a theorem? Anybody remember? We talked about that early on in the year. There is a difference between a postulate and a theorem. A postulate you just accept as fact, okay? And it doesn't have to be proven, all right? You just accept it. They tell it to you, you accept it, okay, it's true. There's really no way to prove it, all right? What is a theorem, though? A theorem kind of looks like a postulate. It sounds like a postulate. It looks like a postulate, but what's the difference between a theorem and a postulate? You're whispering. I can't hear you at all. No, theorems are definitely true. They're definitely true. But here, listen to this. A postulate does not have to be proven, okay? Follow my logic here. A theorem, what? Has to be proven, okay? Or it can be proven, I should say, all right? So a postulate really can't be proven. You just accept it as fact, all right? A theorem can be proven. You can prove it. On some of the theorems, we may prove them, just show you why they're true. I would say most of the time we probably won't, especially in here. But a postulate is just a given statement that you just accept as true. All right, let's do this. Let's talk about a congruent triangle. So now these all deal with triangles. What was yesterday's title? Do you remember what it was? Flip in your notes. It was congruent, I think it's congruent figures, okay? Now, these are congruent postulates, but they're both, we got 2 postulates we're going to learn today, and they're both concerning triangles. And to tell you the truth, I believe the rest of the chapter is probably, I'll say probably, so I'm not, not wrong, but is probably all about triangles, all right? So triangles are the key here, and we're going to deal a lot with triangles. Was it in this class? Did I talk about trigonometry? Did I use that word yesterday? Yeah. There's a whole entire course, right, just on triangles. And we're not going to do a whole entire course, but we're going to do a lot. And this isn't the only chapter we're going to talk about triangles. There's a lot of other chapters that talk about triangles. Believe me, that little 3-sided figure that, you know, it doesn't look like it bothers anybody. Like looks like it's so easy, just 3 little sides. There's a lot to know about 3-sided figures. It's crazy that there's so much to know about it, but there is. And we're just going to start our journey now. So let's draw a triangle. It doesn't matter how we draw it. I'm just going to draw some random triangle. There's nothing really special about it. Let's make it obtuse. Seems like I hardly ever draw obtuse triangles, so let's do an obtuse. Now, watch what I'm going to do. Okay, with the beauty of my program and technology, I can, actually I'm going to group it first of all. So if I just grab one, see, it grabs the whole thing. I'm going to copy and paste. Remember that from yesterday? What's copy? Control C, and what's paste? Control V, and that's exactly what I just did. So what do you think might be true about these 2 triangles? They're congruent to each other. Exactly right, okay? We just finished going over some homework, and I said, how many parts are there to a triangle? 6. There's the 3 what? Sides. So like this side and this side would be equal to each other. Agreed? This side right here and this side right here would be equal to each other. And then the third side would also be equal to each other, okay? What else do we know? If these are congruent triangles, what else do we know? that the angles are equal. The corresponding, listen to the word here. The corresponding angles are equal to each other. Does that mean that this angle right here is equal to this angle down here? No, because they don't match up, do they? They don't correspond to each other. I've been using the word match up. That's fine, but in geometry we say correspond. So which one does this top left angle correspond to over here? The top left. Very good. Okay, now you get the idea, right? What about this bottom left one? We'll give that 2 arcs. That's going to equal this bottom left one. And then the bottom right one is going to equal the bottom right one over here. Okay? So in order to say that these triangles are congruent, we had to show 6 things, didn't we? We had to show the 3 sides, the 3 corresponding sides are equal. We also had to show the 3 corresponding angles are equal. All right? But this is the last time, pretty much the last time, that we have to show all 6 sides being equal. This postulate, this first postulate, we'll give it a name in a second. Let me just get rid of some stuff. I'll tell you what, let's just do this. Let's just copy this and just move it up here. All right? And then, stop. Don't need that. So now what I'm going to do is this. This postulate says that you don't need to know all 6 things of one triangle equaling all 6 things of another triangle. Okay, that's a lot to know, right? 3 sides, 3 angles equaling 3 sides, 3 angles. You can actually tell that these triangles are congruent just with 3 things instead of 6 things, all right? And here's the ones they're going to give you. Tell you what, before we do that, let's label this. Let's call this ABC. And of course, we're going to call this DEF. We don't have to, but that's what we're going to call it. Okay? Everybody watching? Now, this postulate, again, it doesn't have to be proven. It's just accepted as truth. All right? So, let's see which one this is. Okay, so what if they tell you... No. What if they told you that this side right here was equal to this side right here? Okay, is that enough to say that those triangles are congruent?
Yes.
Just knowing one side is equal to the other side? Nah, this could go way out here. This could go way up here, right? Those 2 sides are still congruent to each other. That's not enough. They also tell you that this side and this side are congruent to each other. Okay, that's still not enough to say that these triangles are congruent. I could use this other program that I have to kind of move things around. They do a thing called construction. If you look in the book, they do this thing called constructions. You actually use I'm a geometry teacher, and I always forget the name for this. Oh, a compass. You remember what a compass is? Do you ever use that like in middle school or elementary school? It's that one with the pin on it, right? The needle on it, right? And then it's got a pen attached to a little arm, right? And you make a circle out of it and that kind of thing. Well, constructions are things that you can measure angles, you can measure sides and things like that with a compass, all right? I gave up on teaching constructions several years back. I used to, for years and years, I taught constructions. They're actually kind of fun. But I just got to the point where people, they were supposed to have a compass and they didn't have it. I didn't have enough, right? And so everybody couldn't do it. Then we came to a test. Everybody's like, can I borrow your compass? Can I borrow your compass? And it just was such a pain. I just decided not. And plus, people would poke each other with the sticky part, right? The pin part of the compass. And, right. So I just got so tired of it. I thought it's not even worth it. It is cool to do constructions. It really is. I kind of enjoy teaching it, and they're kind of fun to do. But it just got to be, to me, just a waste of time. So anyway, we're not going to use a compass, but that's what they talk about here. If you look at the book, they do all this stuff with all these arcs on there. They're using construction, and they're using a compass to do that stuff. We skipped that part earlier in the book, so we're not going to do that. But just believe me, this is a postulate. They tell you one more thing. They tell you that angle B is equal to angle E. That's all they tell you. They only tell you 2 sides, and they only tell you 1 angle. But that's enough to say that these 2 triangles are congruent, because there's no way that I could make this triangle look different than this triangle with this information that's given? Okay, think about it. What if I wanted to make this side longer? Then what's going to happen then? If I make DF a little bit longer, what am I going to have to do to EF? Make that a little longer to attach, right? Then would the triangles be congruent? No, they wouldn't. Okay, I could take this side EF, make it a little shorter, all right? But then it's not equal to this. Or I could change the angle of it. Make it the same exact length, but move it up here. But then what's going to happen? DF is going to be shorter. Then it's not going to equal this. Everybody see that? So there's no way in the world, with this information that's given right here, that I could have two different shaped or sized triangles. Everybody hear me on that? So this is all we need to know in order to say that this triangle is equal to this. I shouldn't say equal. What should I say? Congruent, right. In order for this triangle to be congruent to this triangle, this is all I need to know. And that's kind of cool. Now, we have a name. We have, it's actually 3 words, but we have something to name this postulate. Look what they give you. They give you one side and this side right here. Okay, so they give you one pair of equal sides. And then they give you one pair of equal angles. And then what else do they give? A second pair of equal what? Sides. Okay, so they give you, watch this. They give you one pair of sides, right, that are equal to each other. Agreed? A, B, and D, E. Right? They give you a pair of angles that are equal to each other, angle B and angle E, so that's an angle. And they give you a second pair of sides, BC and EF are equal to each other, so that's another what? That's another side, okay? There's a side, there's an angle, there's a side. So they call it the side, angle, side postulate. We can't prove it, but you could try it, right? You can mess around with this. If you had like sticks, okay, and this stick and this stick were the same length, this one and this one were the same length, and the angle between those sticks were exactly the same, there's no way that you could make this triangle look any different than this. I mean, you could take it and like flip it around, but does that mean it's not congruent just because I flipped it? No. All right? You could flip it this way, horizontally, vertically, or anything like that, or just twist it, right, up and down. But they're still going to be congruent to each other. So it's called the side, angle, side postulate. We shorten it. Instead of writing it like that all the time, we can shorten it. So how do you think we're going to shorten this? Very good. We'll call it the side, angle, side postulate. But listen to me. We write down SAS, but we don't say SAS. So if I'm talking to somebody, and I'm saying, oh, these triangles, if I'm talking to you guys, these triangles are congruent because of side, angle, side. You can write it down, SAS, okay, but you always say, I'll put that in quotes, side, angle, side. Everybody got that? So if you needed to write it down, and this could be like a question on a homework or a quiz or a test. Give me the reason why these triangles are congruent to each other. What's the reason? Side, angle, side. That's right. If this side and this side are equal, and the angle in between, that's the key right there. Let me write that down. Oops. No. So look, see that angle right there? I'm going to give you the word that they give you in the book. I'm pretty sure they give it to you. Let me see. Yep, they do. All right. They call it the included. Oops, let's write that a little nicer than that. Why am I so shaky? Included. It's the included angle. What does that mean, the included angle? It means the angle that's what? Yeah, but give me a better word than included. You're not going to define something with the same word. It's where? Where is this angle in reference to these two? Say it. Nah. It's just in between. All right, that's all I'm getting at, okay? It's just in between the two equal sides. You see it? So the two sides that they give you that are equal from here to here, the angle is the one that's in between. So the included angle means it's the one that's in between. That's why we say side, angle, side. That's why we don't say side, side, angle. Everybody got that? All right, we say what? Side, angle, side. That means the angle has got to be the included angle, the one that's between the two sides that they give you. We good with that? Let's do a quick little example. Just stick some numbers in here. They don't do this in the book, but I'm going to. I'm just going to make this. Let's make this 3 sides so we get a triangle. All right, so let's just do this. So copy, paste. All right. Shh. Look, just because I'm taking 2 seconds to draw something up here doesn't mean it's time to just talk to each other. So let's take a look at these. Again, we'll call it ABC, just because I'm lazy, and DEF. Yeah. All right. So here's, what if I told you that that was 5, and then that was 5? Okay, everybody with me? What if I told you, now, I actually drew this so that they're actually the same, but let's just make it up. Let's say that's 6, okay, and that's 6. And let's say I told you this angle right here was, looks close to 90, doesn't it? But let's say it's like 80 degrees. And I told you this was 80 degrees. Everybody got it? So what could I say with the information that I gave you right now? What could I say about these 2 triangles? They're congruent to each other. Give me the reason. What's the reason why they're congruent? Because of side angle side. Because look, I've got one pair of equal sides. I have a second pair of equal sides. And the angle between the 2 sides that they give me are also equal to each other. Everybody see that? What if they told you that that was 80 degrees? Are these triangles necessarily congruent to each other? Stop saying SAS. We don't say that. All right? I know you're doing it just to be dumb, but, congratulations, you've accomplished it. All right, so look. This right here, the angle is in between. This one right here, the angle is not in between. So can you say these triangles are congruent to each other? No, you cannot, okay? You can only say they're congruent if you've got 2 pairs of equal sides and then the angle in between those 2 sides are equal to each other. All right, so let's write the congruent statement. This is a very, very strong possibility this could be on a quiz or a test. Something like this. Not this exact one, but something like it, okay? So you could call this anything you want using A, B, and C. What would you want to... Let's not call it A, B, C. Let's just be different. We're not going to be lazy. Well, you got to use A, B, and C, but I'm not going to put it in that order. Say it. BAC. Okay, let's call it BAC. So watch. We decided on BAC. So if I ask you to write a congruent statement, all right, you might want to write that in your notes. Congruent statement. All right, what a congruent statement is, triangle this is congruent to triangle that. All right, so we called it triangle BAC. All right, and we got to figure out what's it congruent to over here. Now look, where did I start? I started at B. Now listen to me. This is very important. So pay attention. Okay, this is not a time to make little jokes. Okay, it's not that funny anyway. Nobody else is laughing. Okay, except for just 2 people. All right. So listen to me. How do I know? Now this one's super easy because they're right next to each other. I didn't twist. I didn't flip. I didn't do anything. Okay, it's very easy to see which one matches up with B. But sometimes they do twist the triangle. Sometimes they flip it horizontally. Sometimes they flip it vertically, okay? And sometimes it's hard to tell which one goes with what. So here's a little trick. Look at angle B, right? Because I got to figure out what goes with B. Now you know which one goes with B. It's very simple, don't you? Isn't it? Right? The B and the E match up very easily. But what if I took this and I flipped it around or I twisted it? How do I know which one goes with B? You look to see the side that's opposite. What's opposite angle B? This side 6. The side 6. Do you see that? So what you do is you come over to the other triangle, look for 6. What angle is opposite this side 6? E is. So that means they're both opposite equal sides, so those 2 angles are the ones that are equal to each other. You see that? You're going to have some problems that are way harder than this. This is super easy. This is just getting you started. All right? This triangle right here is just getting you started. They're going to, again, I said it's like the 5th time I said this today. but they're going to flip them, they're going to twist them, and all that kind of stuff, all right? And you got to be able to know which one goes with what, because just looking at it, sometimes it's very difficult to see which angle goes with what. So if there's a side that's opposite angle B, I look for the side that's opposite, I look for that same side, which is 6. What's opposite the 6? The E is. So the E and the B, they go together. So what do I put right here? What's my first letter? It's going to be E. All right. Now I went A. Which one is the A? It's the one with the 80-degree angle. Which one over here has got the 80-degree angle? The D. So I know that they go together. Now once I get 2 of them, I know the third one has to be what? Right? I already used E, I already used D, so the other one has to be what? F. And let's just take a look. Look at the C. The C is opposite what? The 5. What's opposite the 5 over here? The F is opposite the 5. All right, so you know that they go together. What I just said right there is really important. Some of you guys are just blowing me off, okay? I could tell. All right, so I'm telling you, it's really important that you understand what I was just saying right there. All right? Everybody got it? Okay, we got one more to do. I said we had 2 postulates. We're going to do another postulate. So let's draw another triangle. Let's draw another triangle. Let's make it look a little different than we've been making them. Yeah, that's good right there. That's good right there. Okay. Let's group that. Let's copy, paste. All right, so let's use different letters. I'm tired of ABC. P, Q, R. And let's call this X, Y, Z. They use that a lot in the geometry book, so let's use it here. I hope the jokes are worth not paying attention. Somehow, I don't think they are. Because when I pass out quizzes and tests and you do poorly on them, first thing I go back to is all the times you fooled around and didn't pay attention in class. That's what I go back to. So, anyway, just saying. All right, here's what they're going to do. They're going to give you some different information. They're going to say that this angle and this angle are equal to each other. They're going to say that this side right here and this side are equal to each other. And they're also going to tell you another angle. So they're going to say angle R and angle Z are equal to each other. Okay? This is our second postulate. Okay? What do you think? Now that you saw the first one, you probably should be able to figure out the name of this postulate. That's enough. Okay, by the way, that's enough information to say that these triangles are congruent to each other. Okay? Can you prove it? No. It's just an accepted fact. Okay? You just accept it. You could try all you want. Right? You could take some sticks, make this stick and this stick the same length, and then have another stick at a certain angle and another stick at a certain angle, and where they meet are going to be exactly the same place as they would meet right here. There's no way that you could get this to be a different shape than this with the given information. All right? So what do you think we're going to call this postulate now? It's not going to be side, angle, side like the first one is. What do you think? Very good. I like that. It's angle, side, angle. Again, it's a postulate. So I said it already a bunch of times, but you cannot prove a postulate. You just accept it. Just accept it as fact. The next lesson we do are theorems, and you can prove those theorems. We may prove 1 or 2 of them. I'm not really sure. I can't remember which ones are easy, which ones are not so easy. But this one is just accepted. Now, what do I call that side then? That side is the what? It's in between those 2 angles. So it's the included what? It's not the included angle, it's a side. So it's the included what? Side. So it's the side that's between the 2 angles that they give you. Everybody see it? Yeah? What if, this is a little bit of a loaded question if you know about this a little bit, but watch. What if they told you that this and this were equal? Is that angle side angle? No. Why not? No. Oh, why are you eating in my class? I told you not to eat. Do I need to write you up?
No, wait, Mama.
I told the whole class. I made a big deal about not eating in here. But when class started, and you're chomping away, I can't even understand you because you got food in your mouth. So this is the included side. Is this the included side? No, it's not. So can I say these triangles are congruent because of angle, side, angle? No. Sneak preview. These triangles actually are congruent to each other even with this information. Because, check this out. How many degrees are in a triangle altogether? 180. So watch. If these two angles are equal to these two angles, we're going to do this later on, but I'm just getting you to think a little bit first. What do you think might be true about angle P and angle X? Let's say they add up to 120, and these two add up to the same thing, right? Because they're equal, right? These two are equal to these two. So if these two add up to 120, these two add up to 120, what's angle P going to be? It's going to be 60. What's angle X going to be? 60. So what's true about angle P and angle X? They must equal each other, right? And then, watch this. This is kind of a theorem, and we're kind of proving another theorem that we haven't got to yet. We will get to this, okay, in a day or two, right? But now look at it. Now you could look at this as what? Angle, side, angle. You see that? All right? So that's kind of a proof of another theorem that I probably shouldn't have done this, but we're going to get to it at another point. But this is actually another proof. So could you have this side and this side be equal to each other and them still be congruent? Yes, you could. But they're not congruent because of angle, side, angle. You follow me? That original stuff that we did? All right, let's get rid of all that. There we go. And let's put that back where it was. There we go. Okay? These are congruent because of angle, side, angle. All right. Yeah, I don't know why we're packing up because I'm not finished. 4-3. So we are doing, of course, we are doing section 4-4. Is it 4-4? No, it's 4-3. 4-3. I gave you a lesson plan on Monday. Why don't you have it? I might have some. Let me check. So it's 165, 166. Everybody watch. I'm not done. It's 1 to 15 and 20 to 23. All right. So do your best on this. This is a little different. This is not your normal everyday math kind of stuff. All right. But let's take what we talked about today and apply it. That is your homework. That is due on Tuesday. You got an extra day to get it done because you got a long weekend. All right. We don't have school next Friday.
Wait, we don't have school Monday or Friday?
Monday or Friday next week. You're off of school. I go to the dentist on Monday and I still have to come to school on Friday. So
Is that in Missouri?
it's because the teachers, you're not taking that. Yeah, you can take a picture of it.